All right, we are going to, in these videos, we'll see how many there are, we're going to take a look at just some of the material for the quiz coming up. So this is a review for that. The big main topics we've covered so far in this chapter have included basically graphing systems of equations, all right? So graphing systems. And then we've talked about solving them using substitution. All right, I'll just put that. And then we've also had 2 lessons on solving using elimination, which is a far more efficient way of solving systems of equations. So when we talk about solving systems algebraically, that's these 2 right here, because that's doing it without the aid of a graph, all right? And then graphing systems is purely just slope-intercept form and all of that. So most of what we talk about in this video is going to concentrate on the algebraic solutions of these, but we will talk about a few other things. So let's get started. So the first thing is when you do graphically solve these, all right, and you're looking at these graphically, there's some things that connections we want you to make. So the main connections are that if they meet in one point, all right, if they meet in one point only, that means there's one solution, all right. In the book calls that it's completely eluding me. It's such a weird term. Book calls that consistent, all right, and calls that independent, consistent and independent, all right. That's your one solution. So like the green and the blue line, where these guys are meeting, that would be an example of a consistent independent solution, all right, because it's only meeting in one spot. The next thing you can have is where you have basically two lines that lie on top of each other, right? So in effect, they're the same line. All right, but they might have different ways of writing the same line. So it would be kind of like if we had this y equals 2x minus 1, and then somebody else thought it would be fun to call this, you know, I don't know, we'll say 2y minus 4x equals negative 2. Right, which is basically what I did is I multiplied that by 2 and I moved the x over to the other side. Okay, so that's when you have a situation like that where you have 2 lines on top of each other. That is called consistent. Consistent always means there is a solution, right? But it's called consistent dependent because your solution depends upon which x value you put in, and then that y value will be a solution, and then you can put in a different x value that lies on the line and get another one. So the reason for that is because there is an infinite number of solutions, right? Infinite number of solutions. Okay, so that's the first 2, and then the third one is when you have parallel lines. All right, when you have parallel lines, that means they don't touch. All right, and if they don't touch and they can't meet each other, then there's no solution. All right, so we call that inconsistent. All right, the reason there's no solution is because if you think specifically about what a system of equations is, it's taking 2 equations and saying, okay, where they intersect is where you have a point or points that work for both of them, and if they never intersect, then nothing exists for that. So if it's inconsistent, there's no solution. That's all there is to it. So like an example of that would be this one right here, y equals minus 2x plus 3, and y equals negative 2x minus 3. And you can see from looking at these, right, that your slopes are the same. All right? You both have a slope of negative 2. But this one has a y-intercept of negative 3, which is where it crosses right there. This one has a y-intercept of 3 up here. Okay? So you're looking at lines that their equations look really similar, but their y-intercepts are different. And so when you see that, that should be kind of a red flag. All right, so if I look at number 1, all right, 2x minus 1 and negative 2x plus 3. Well, 2x minus 1 is, which one is that? That's this, this blue one right here, this light blue one. So that's 2x minus 1. And then negative 2x plus 3 is this guy right here, the darker blue one. And those two meet right here. And so we would say the solution for that would be the point 1, 1. And then we would call that consistent. I'm just going to call it consists. And then that would be independent. All right. And then number 2, negative 2x plus 3 and negative 2x minus 3 was the example we were just talking about. And that is a good old no solution, because they're parallel lines, and we would call that inconsistent. All right. So that's kind of how numbers of solutions work, and just a kind of a recap about how the whole graphing thing, how your results look. Okay, so I'm going to stop the vid here, and then we'll pick up elsewhere.